Theorem 2.5. Let f from D to D be a one-to-one analytic map of D onto itself and suppose f of a equal to 0. Then there is a complex number C with mod C equal to 1 and f equal to C phi alpha. So here we have f from D to D is a one-to-one analytic map of D onto itself and suppose f of a equal to 0. Then there exists a complex number C with mod C equal to 1 and f equal to C phi alpha. Its proof is, since we have f is 1-to-1 and onto, so there is an analytic function, that is g from D to D such that g of f of z equal to z for mod z less than 1. So here we have already given that f is 1-to-1 and onto. So there exists an analytic function g from D to D and g of f of z equal to z for mod z less than 1. Then here we are going to apply inequality mod f dash of a less than or equal to 1 minus mod alpha square by 1 minus mod a square. Then both f and g gives mod f dash of a less than or equal to 1 minus mod alpha square by 1 minus mod a square. Since alpha equal to f of a equal to 0, so we can apply 0 here. Then we get mod f dash of a less than or equal to 1 minus 0 by 1 minus 1 by a square, which is equal to 1 by 1 minus mod a square. So we can take the inverse, that is mod f dash of a equal to 1 minus mod a square inverse. That is f dash of a less than or equal to 1 minus mod a square whole inverse. Then g of f of z equal to z. So g dash of f of z into f dash of z equal to 1. That is equation number 1. So g dash of f of z equal to 1 by f dash of z. That is at z equal to a, mod g dash of f of a equal to 1 by mod f dash of a. That is, we know that f of a equal to 0. So here we can apply that. So we get mod g dash of 0 equal to 1 by mod f dash of a. That is less than or equal to 1 by mod a minus mod 1 by 1 minus mod a square whole inverse. We already find that mod f dash of a equal to 1 minus mod a square whole inverse. So here we get that g dash of 0, mod g dash of 0 less than or equal to 1 by 1 minus mod a square inverse, which is equal to 1 minus mod a square. That is, we can write mod g dash of 0 less than or equal to 1 minus mod a square. But since both f dash of 0, g dash of 0 equal to 1, then we are applying another formula, that is f of z equal to phi minus alpha of c phi a of z. That is, we already said that alpha equal to f of a equal to 0. Also phi a of z equal to z minus a by 1 minus a conjugate z and phi naught of z equal to z. Here f of z equal to phi naught of c of phi a of z. So phi of z here z is c of c into phi a of z, that is f of z equal to c of c into phi a of z, that is equal to f equal to c phi alpha. So in particular a equal to z and f equal to c phi alpha for some c with mod c equal to 1.